So I want to make a connection here. Here is that line that we talked about that works, where 12 is 12. It'd be where the x-intercept 6 and the y-intercept is 4. And then I'm going to try my best to make as straight of a line as possible.
What if it's not straight? That was actually really good.
Yeah, I kind of missed that one dot a little bit.
That was actually good.
Okay, so here is that line where it is equal to 12. But we've been working with these inequalities. So the first question I'm going to ask is, does the line work here? Well, when we had 0.60, did we get 12? Yeah. When we had if we plug in 4, this point is 0, 4. If we plug that in, we get this. Does that point work? So it looks like the line works, okay? But this is not just the line, because if it was just the line, it'd be 2x plus 3y equals 12. This is 2x plus 3y is less than or equal to 12. So the line works, but there's other stuff that works is what that means. Right? So what might be a nice point to test?
0.
Well, there isn't a point 0. It'd be an ordered pair. I think I know what you're saying, though.
0,
0, 0, the origin. Let's test out the origin. So if I slap the origin up in here, I get 0 is less than or equal to 12. Is the origin true? So I'm going to just put a dot there saying that's true. Someone pick something else for me to test close to the origin. Yeah, Vinny? What else? Just something close to the origin to test out. 2 what? It needs an ordered pair, right? 2, 2. Okay. So 2, 2 would give me 4 plus 6, which is 11. So does 0.22 work? It does work. And what do you notice about? Because 11 is less than 12. Someone pick a point from over here for me to try out. Not too crazy of numbers though. Let's try one from over there. Ivy? 8, 8. Okay, let's try out 8, 8. And that'd give me 16 plus 24, 30, 40 is less than or equal to 12. Is that true? No, so 8, 8 doesn't work. I'll put an X up there. So let's test out 6, 1. That'd be 12 plus 3 is less than or equal to 12. Is 15 less than or equal to 12? So I know that 6, 1 also doesn't work. So here's what I notice. Above this line doesn't work, but everything below this line does work. So I'm going to shade it. This is shading.
So any of those ones?
Anything there is going to work. And everything on the line. Kind of cool, huh? And we can always test it. We're gonna take that a little further. This is the first time we've seen it. We're going to take that a little further. So there's 4. This is only showing 2 at a time. But there's 4 different ones of these. Groups 1, 2, and 3, you're going to do the first 2. 4, 5, 6, you're going to do the second 2. You're just going to test points. You need some kind of system. If your point works, do this. If it doesn't work, do this. I personally like the 2-color system. Some people did X's and then open circles. Whatever you do, I don't care as long as you're organized. So what I mean is, like on the first one, you could pick some points to test, like the origin is 0. Uh-oh, I messed up. I didn't click the overlay. Okay, is 0 greater than or equal to 0? Okay, so then I'd like put a dot there saying it works. And then I would test maybe 0.41. Let's say 4.1. And that would mean 4 is greater than or equal to 1. Is that true? Yeah, so that works. So I'll put it. Okay, and then maybe I'd try negative 2, 2. Is negative 2 greater than 2? No, so then I'm going to put an X there. Something like that. Test out points and see what you can see, okay? So, again, groups 1, 2, 3 are going to do the first 2. 4, 5, 6 are going to do the second 2. Get after it. All of you use lots of points to do these. What I'm going to do is I'm going to show you how you can test your points versus the line I'm going to make. So, this first one, I notice it's in slope-intercept form if I rewrite it like so. Y is less than or equal to x, which tells me that it passes through the origin because my y-intercept 0, and I have a slope of 1. And a slope of 1 tells me up 1 over 1 for my slope. So is everybody good with my reference line here? This line is y equals x. Okay. So we know the line works. We already tested the origin, which is on the line. The line worked. We also learned that this point down here worked. And what you would have noticed is any point that's below this line, no matter where you picked it, also worked. And any point you picked above the line up here. What is going on with my pencil? Maybe it died? I didn't get a notification. All right, we're going to do this old school. All right. So anything you picked up here didn't work. So if we're going to shade this thing, we would shade everything below.
Did I not do that?
All right, let's do this with the next one. So this next inequality, to get y alone, we're going to divide both things by -2. And that just simplifies to y is less than 2. Remember, when I multiply or divide a negative, everything becomes its opposite. So if y is less than 2, it's less than or equal to, isn't it, on your notes? Okay, that gives me this line right here. And does that line work? Is 2 less than or equal to 2? Is it? Yes, that line works. So, what other stuff worked? The stuff above it or below it? Below it, all the stuff that's less. Okay? All the stuff that's less also worked. So, for these next two, I'm going to get this to be x only. X is less than 0. Now, here's the question I have. Does 0 work here? Is 0 less than 0? No. 0 doesn't work. So, I'm struggling. I'm struggling. Here it is. So, here's the line that's the reference for x being 0. I'm doing a dash line because the line doesn't work. So I want you to make the connection here between when we were graphing on a number line. When we were graphing on a number line, what did we do if it didn't work, but it was our reference point? Well, not on the number line. If the open circle, yeah, thanks, Sean. Open circle when it didn't work, but it's still our reference point. This line doesn't work, but it's still our reference point. Solid circle on a number line worked and was a reference point. Solid line works and it's a reference point. So make that connection to the number line. So less than 0. Which side is going to give me answers that work? Left or right? Left side. This is all the stuff that's less. All the way right up to the line, but not the line itself. I can get closer. The left side.
I think you could get even closer.
I could, but I'm not going to mess anymore. So, this next one, standard form, what's the easiest way to graph this?
X1.
Intercepts. The x-intercepts 10, the y-intercepts 10. Does the line work?
Yes, sir.
Look at your symbol.
No.
Oh no, I just lost it.
Because it's 10 plus 10. So
The line actually does not work. And here's why. Let's say xy was 0.55. This point right here. 5. Right there. Okay? Is 10 greater than 10? No, so the line is still my reference point, but it doesn't work, therefore it's dashed. What might be the easiest point to check with this one? The origin. Let's check it. Is 0 plus 0 greater than 10? No, so since the origin doesn't work, I know this side has to be shaded over here. All right, so everything you checked that worked is up there. Everything you checked that didn't work is below that line. So, I'm a little worried, but it's all right, I got you, that people wrote different lines. All of these come from the x minus y equals 5 as our reference line, which means our x on all of them, we have a x-intercept of 5 and a y-intercept of -5 on everything. That doesn't change. It's just an inequality symbol that changes, or an equal sign. Right? This is the standard form. So looking at this first one, does the line work? Is the question. So I know just by looking at the symbol, let's say you don't. What could I test? A point on the line, right? Which would be something like 5, 0. We could test 5, 0. And if I test 5, 0, I get 5 is less than 5. Is that true? No, so I know the line doesn't work, but it's still my reference point. So I lay down a dashed line there. Yeah, Ivy?
Well, I didn't test anything. I just
I don't test anything either. I know it doesn't say or equal to, so it doesn't equal 5. So since it doesn't equal 5, I know dashed. But I'm saying, let's say you weren't there yet. You could test 5, 0, and see if it does work or not. But next, to see for shading, I would test the origin. So let's test 0, 0. Is 0 less than 5? Yes, so if the origin is true, that side needs to be shaded. And if you want to be real careful, you can test something from the other side to make sure it's not true. But you don't really need to. If 0, 0 works, make sure it's shaded. So looking at the next one, the top right. It says less than or equal to. So what does that mean about my line? Does my line work?
It's not, yeah.
5 works, right? To get a sum of 5 works. So a solid line. Let's test the origin. Is 0 less than or equal to 5? Yes, so I got a shade above. As Zeph pointed out, these problems are a little shady. Okay. Oh, I thought you said that.
I said sketchy just to use overused joke.
Okay, this next one, x minus y is greater than 5. Does a reference line work? Let's test out a point if you don't. Okay, is 5 greater than 5? No, so our line can't work. So it's dashed. Okay. What point should we check? Because it's the easiest. The origin is 0 greater than 5.
No.
No, so the origin needs to not work, which means below. Last one. Does the line work? Yes, because it can equal 5. There's my reference line. It does work. Let's test the origin. Is 0 greater than 5? No, 0 is not greater than 5. So I'm shading below. You can always, after you shade, test out a point from the shaded area, test out a point from the non-shaded area. You can always test points. Hey, I know that we might not all be done, but I need to make sure we have time for what we've got to do next. So, on number 2, this is kind of the process. If you're struggling getting the reference line, we need a reference line first. So is everybody seeing, x equals 3 there as the reference line? The dashed line is x equals 3. But does x, the shaded part would be what compared to 3? So x is greater than 3 would be that inequality. The reason it has to be greater than is, does 3 work?
No.
No, that's why it's a dashed line, just like the open circle on a number line. So looking at B, our reference is y equals -2. That's our reference line. But do things that are more than -2 or less than -2 work? Less than. But this one I need an or equal to with, because that solid line that says -2 does work. Right, so it's less than or equal to. Okay. The reference line for C and D are both y equals x. I know that because the y-intercept is 0 and the slope is 1, right? Y equals mx plus b. The y-intercept is 0 and the slope is 1. So that's my reference line. No. So, for this first one, what point would you test? Well, what point do you know works? Pick an easy point that you know works. Like 0, 1 maybe?
0, 2.
I know 0, 1 works.
0, 0.
So 0, 1, how do I make that true? What symbol?
This one.
I put those in the wrong spots.
No, 1 must have
1 has to be greater, right? So y has to be greater than x.
the alligator
Okay.
sign.
Now, so that's how you can do it by testing a point. But since this is in relation to y and y is up and down, if it's greater than x, that's above your line. You can only do that because it's in relation to y. But you can also test a point. So y is greater than x. Does the line work? Our reference line, does it work?
Yes.
It's dashed. So it means doesn't work. The line doesn't work. So the next one, let's grab a point from here, 0, -2. To make that true, our symbol needs to be like this, right? So y needs to be less than x, but does the line work?
Yeah.
Yes, so I need the or equal to in this case. y is less than or equal to x. Okay. It's all about, and then if let's say you get an equation and you're not sure, or an inequality you're not sure, guess what? Test some ordered pairs. If the shaded part should work, the unshaded part shouldn't work. Right? Is everybody good with the y equals x there?
Yeah.
Okay, slope-intercept form. Grab the y-intercept and the slope. The slope is 1. If it's y equals x, we don't write that coefficient because 1 times x is x. We know it's not 0 because 0 times x would be 0. So we know there's a 1 there even if we don't write it. Cool.